Evening all, how we all doing? Well done, Night Shadow. I hope you're enjoying your vacation. Yeah, we were down in Plymouth. Her son has just moved into a new place, so we had to go down and help him move and carry loads of stuff around and take him shopping for beds and that sort of thing. It's at his very first place of his own. It's been many years since I felt that feeling. Hey, three amigos. DevShed is going well, thank you. And after our first round of recruitment didn't really go anywhere, we're planning a second round once we get this demo update done and dusted. Focusing on one thing at a time. I think Claire's busy. Oh no, she's back. So what have I been doing over the past week? Well, other than driving all over the shop, helping people move house, I have been working on some Galaxy stuff. So specifically, one of the bugs we had was that Lofi 9352 was not loading properly or displaying properly in the game. And in addition to that, a lot of the sol data was not displaying on the new sensor readouts that we've got, simply because the data wasn't there. So with the procedural systems, obviously we're generating a hell of a lot more data than we were putting into the manual systems. So Lofi's a manual system as well. So that required quite a big change on how we do things. So the way we were doing it, and Sajay will fall into that category as well, is that we were checking against the galactic coordinates for the subsector that you were currently in, and then generating either just a procedural system or Lofi or Sol, or in this case Sajay, and they were separate functions. Now that's not very expandable in the long term. Obviously, if we were doing a separate function for every unique location in the galaxy, then this list would grow massive. So it was never really something that we could live with long term. But now that we're generating so much more data, it made sense to roll that into a single function. So what I've been doing is I've been taking the data for the manually created systems, which is this lot here, and I've been rolling that data into the procedural system. So it's a bit of a mess at the moment because I've had to sort of pull it apart a little bit. So what we were doing was this stuff here and this stuff down here to create our procedural systems. So what I'm having to do now is crowbar in a lot of that data for the manually created systems. And all of that data is coming from a SQLite database, right, which is this. So we've got two tables. We've got the basic information, which is what the Galaxy Gen uses to place the star in the galaxy. So here you can see here we've got Sol and Lofi 9352. Now that we have this data structure, we can add manual systems with a lot more specificity. So that does also include the planets orbiting those systems. So you can actually edit this database because it's just a SQLite file in the content folder. So you could actually create your own custom star system here just by kind of copying some of the data and then also add planets to that system, including their orbital criteria and such as well. So the job that I've been doing is making sure that we have the right data here and also the most minimal amount of data here in order to drive the procedural system. So it's been one of those kind of rabbit holes that just keeps getting deeper and deeper, and that's kind of been the story of my life this week. As soon as I think I've gotten to the bottom of it, there's another layer of stuff that's needed. But I was about to do a test, because I've just... Which bit did I just do? So I've just sorted out the planet type, which I then need to input into the database. So one of the issues we have, obviously, with the SQLite database is we don't have the same kind of enums that we would have within Unreal Engine itself. So we're having to use just a simple integer value in order to turn that into a byte, which we're doing here, in order to set the enum, which means we need to know beforehand what those values are. So one benefit we have of doing this is that this is actually also the groundwork for the in-game Star System Designer tool, which will be put out at some point later this year. Because what that's going to do is that's simply going to populate the database with the correct values, and it will mask things like these integer values with drop-downs. So it will store the data as an integer, but in the UI it will be a drop-down to make that easier to manage. But it means that we're doing some of the work ahead of time already in preparation for that tool existing. So that's going to make life easier in the future, even though it's taking time now to sort it all out. So let's go ahead and update some of these values. So I'm just going to pop this on another screen a minute. Basically, I'm just setting the planet type based on these numerical values. So Venus, for example, would be a 19. Earth is a 20. Mars is a 19. Ceres is an 18. Actually, no, it's not. It's a dwarf planet, isn't it? So that would be a 17. Jupiter is a 22, Saturn is a 22, Uranus and Neptune are both 27s, Pluto is a 17, and so are the other trans-Neptunian objects. So I've basically just populated that column with all those types as a numerical value. So if I now close that database, we should be able to read it from within the game. So the first half of the data is being read successfully, and you'll see that compared to the procedural systems, we've also got some flavor text in there as well, and that flavor text is also contained within the database. So what it does is it checks the field, and if the field has any text, then it injects that into the display for a bit of flavor text. So that's all working. I'm starting to see some bits here. So the system that saves knowledge uses the ID, which is also doubled up as the seed. So you can see that some of these have been explored and some haven't. I imagine these ones are the gas giants. Orbital distance is wrong on those though. Yes, Anasi, once you've discovered them. Okay, so that one, those are right there. Yeah, so the details here that are not coming up with any values, those are the ones which need to be fleshed out. So this one is actually Earth. That's interesting. I think the IDs might be mixed up because that one's Venus, and the tech and the life should be showing on Mars, really, but we shall see. Yeah, so some of the values here are correct. Obviously we're not picking up any density or mass, so they just need hooking up. But yeah, so that there's a lot of additional data here which we're calculating dynamically, and it made more sense to add that to the procedural system rather than having a completely separate function for it, because we're already doing that work. It didn't really make sense to start duplicating up on that. This is the Sol system data, Anasi, and right now it's not reading everything properly and it's not filling everything out properly. So that's what I've been working on, just making sure that we go through the same steps that it's going through here, and we replace some of the procedural values with manually specified values. It's Uranus in the UK, Dave. I think it's Americans that call it Uranus. I can't speak for Europe. I don't know how it's pronounced there. I've not looked at those yet, Anasi, because I've been spending all week working on this. Obviously the gas giant data needs to be plugged into there. So we should also be pulling out the flavor text for this as well. So let's just grab that. Think we're setting that anywhere else. Oh yeah, that's just a central star, so we can overwrite that. I'm not sure, CSI. I shall go through it and have a look. So on the old version, which we still have the function for, I didn't actually delete it just in case. There. So this is an example of what we used to do. We would go through and add, basically construct the system in isolation rather than going through the usual procedural stuff, which means that everything had just manually specified values, which is all right, but since we did this, we've obviously added a hell of a lot more stuff to the sensors display. So there's a lot of information that's on the sensors now, which is not catered for here. So that all needed to be expanded upon. And again, it made more sense just to do away with this and do it properly. But yeah, so here we have, so Mercury is 1, Venus should be 2, Earth should be 3, so on and so on. Saturn is 7. Yeah, so they are following numerically all the way up to Sedna being 14. And unless I'm mistaken, the data in here should be the same. So Sedna is 14, Saturn is 7, Earth is 3. Yeah, so it's all there. And again, we've got our flavor text in here as well, so that's something we can just pop in. Hey, you're welcome well today. Hey, Don. Yeah, I'll get round to that one, Anasi. It's what's happening there is that when we spawn the procedural FTL civilization, it handcrafts an Earth-like world as their home world, but it doesn't necessarily prevent another Earth-like world spawning in that system, if the conditions are right for it. So the system doesn't cater for the fact that there might actually be another Earth-like world, and it doesn't really know how to handle it, because all the work it puts into giving that race a homeworld is very much focused on that. So I need to add in some additional handling if there's another Earth-like world within a system which is already inhabited. It's one of those edge cases that catches you out. Right, so we've got all of our orbital data there. That all looks populated. And I imagine the biggest issue with it is probably the gas giants not being hooked up properly yet. What was I going to do? Yeah, I think we were just checking the IDs, weren't we? Which are correct, so we don't need to worry about that. So when we read our database, we're setting our seed here, so we're taking the ID from the database, we're setting our seed, and then when we actually construct like the mother load of data at the end, we are setting that seed. So if the seed is higher than 0, then we're setting it from the database. If it's 0, i.e. someone hasn't bothered to set the seed, then it will just generate a random one. So that we're setting, those are already set. That we're setting. That we're setting. Yeah, so actor class is another one we're going to have to set because yeah, so we're not going to be using any of these procedural ones. The soul planets in particular have a different type of actor to the procedural ones, in that they've got manually created textures and such. So we're probably just going to have to use the ID for that. In fact, we will use the ID for that. Yeah, so I think what we'll do, if we take our seed, we do a select on the class. It's going to be a long list. Move it down here a bit. Right, so Mercury, Venus, Earth, Mars, that's interesting. Why don't we have a manual one for Ceres? I don't know how you pronounce Ceres, by the way. Is it Ceres, Ceres? I've never actually heard it pronounced. I might have actually been using Mercury for that. I'll double check afterwards. Then we have Jupiter. Saturn. Uranus. Neptune. Pluto. And I think I was using procedural planets for the other dwarf planets. Let's just check on here a minute. What class were we using? Oh yeah, procedural for that one. Nice and simple. Right, that at least means we're spawning the right actor type for there. We've got a bit of redundancy on here as well. So we'll do a similar thing here, where if the text is empty, then we will use our other descriptions. And basically the level 3 one is the one where we will be describing surface details. I'll just pop that in there for now. Again, this is like super spaghettified at the moment, but that will be cleaned up once it's all working. Sorry, that was my Discord pinging. Forgot to set myself to do not disturb. Hey Antonio, all good, thanks. Yeah, sorry AJ. I always try and remember to set it to do not disturb, and I invariably always forget. Now, I'm not actually sure why we're using two different versions of this. We might be able to double them up a little bit and save having to repeat ourselves. Because ultimately we're setting the same data. Yeah, why don't we build our data first and then do that after? Then we don't need that then. Right, so right, let's just check those ones a minute. I'm going through this step by step and just building out the data one bit at a time, otherwise it gets a little bit confusing. Right, so the high level data's there, that's all fine. The star data is all there. This was an interesting one actually, because 50% of this is being calculated from some of the input values, so making sure it matched what we had on record for Sol was actually a little bit tricky. Like the mass and the density values, even if they were ever so slightly off, then of course it wouldn't then exactly equal what we had stored for Sol, so that required a little bit of tweaking. And the same here with the metallicity. So I had to make sure that the metals was exactly 1.69 in order to reach 0 on that, which is the baseline for Sol. But that's all okay. We need to manually specify the scattered disk extent. That's basically the Kuiper belt. Because it works out the Kuiper belt from the procedural systems based on running out of mass in the protoplanetary disk. So we have our planetary disk, it starts deducting mass from it every time it creates a planet, and then when that mass runs out, it says, right, so that's where the Kuiper belt starts, when we run out of mass. But of course we're not doing that with a manual system, so we need to just make sure that we maybe manually specify those values. Right, so at least we've got scan data for these. Why are they all the same distance though? That's a little bit weird. So that's correct for Mars. That's correct. I see what's happened. It's they all have the same location. So that would be Ceres. That would be Jupiter, Saturn, Neptune and Uranus there. And then those are the dwarf planets. So that one would be Pluto. It's interesting that it's not picking up the description there. Did I not actually call it the right thing? Hang on, just check the database. called the field flavor text, which means that it should be reading flavor text on here. Where are we? Reading flavor text, converting that to that. Right, so let's set a bunch of this for the gas giants. Actually, saying that, see, some of this work we can actually do for both the gas giants and the terrestrial worlds, because that's just all the orbital data. We don't need to do that twice. Right, let's move all that out of the way a minute. So if we do that first, that gets that bit out of the way, and then we can do that as well. So if we add that to that, because that's relevant whether it's a gas giant or not. Right, and then specifically for gas giants, we need to add the gas envelope to do the final planet mass. That's the one we're not calculating at the moment. So there's a bit of a decision to be made on this because, again, because we're manually creating a star system here, and as much if we're making Sol, we can just look the values up. If we're not making Sol, we're making something completely proprietary as part of like one of the handcrafted story races, for example. Like, do we guess at the mass of the planet, or do we use something like the density instead? Because what we could do, knowing the radius obviously gives us the volume, and then if we put some density against that, that'll give us the mass. So it's probably easier to use density as a manual value rather than mass as a manual value. It's slightly easier to be able to guess at what the density might be, based on rock composition and that sort of thing. Believe it or not, there's a lot of science that goes into this. Right, so we're going to get a 0 value until we specify that, so we'll leave that for now. So atmosphere, we're doing at a later point. Layer densities, yeah, we're not adding those at the moment. these values. Again, we can do that. We can do that after we've done those bits, because again, these are relevant to both rocky planets and gas giants. So I think what we'll do is we'll do the orbital characteristics as a unified thing. We'll do the atmospherics and things like densities based on planet type, and then we'll go back to more generically working out this sort of thing, which means we then need that. Final planet type we're specifying manually, and yeah, and then we can do those as well, unified. I'll actually collapse all this properly into its own subgraph once it's all working. Stick another sequence in there just to clean it up a bit. This is the thing with blueprints, it's all a bit spaghetti until you clean it up. Right, so that ticks those boxes, and then we shouldn't be doing anything different there. Nope. Or there. Nope. So tick, tick. I might need to work some of this backwards. Obviously we already know what the radius of the gas giant is, so we can skip some of this. Yeah, and then we can work that out from there. This bug, in a roundabout way, Hurricane, is the one where when you click on Loci 9352, there's nothing there. So you visit the system, nothing is loading, and there's no data for that system. And also there's lots of blank data in the Sol system as well. And the reason for all of that is because the new Galaxy system and the new sensor system have a lot more data on them. So we're having to basically fill in the blanks. I think there's going to be a bit of chicken and egg ordering to do on this as well. Let's just see what we're missing a minute. Okay, that's fixed the distances, so Mercury, Venus, Earth, Mars, Ceres, Jupiter, Saturn, Uranus, Neptune, Pluto, whatever it's called, Maki, and the other two that I can't remember. Sedna, that would be Sedna, wouldn't it? Right, so we are lacking. I'm guessing because it's lacking the mass and the density, it can't work out those. Should have the inclination though. Okay. I'm sure we will at some point. I think we're setting. Yeah, so there's planet tilt there. Then we've got the planet inclination there. So, yeah, we don't want that one. We want that one. So we are definitely driving that one in there. I think because it was using the old procedural value, it was coming up with 0, which is why it was saying NA. So that should have an inclination. Ah, yeah, there we go, that's better. Great, I'm going to go our orbital velocity as well. Let me just check that a minute. Bright, too bright. So Earth's orbital velocity is apparently 29.78 kilometers per second. Okay, what about Mercury? Uh, 47.87 it should be. Okay, so we seem to be overestimating our orbital velocities a little bit. Although it's getting the period correct. Let's check Mercury. So it should be 88 days. Which it is. Great, so that bit's working. I'll go back and double check the math on the orbital velocity, because that's not what Google is saying it should be. But then, who's to say Google's right? I'll double check the math. Might actually be relating to the fact that we still don't have mass values. so how are we doing that on here? So we're taking... So where are we doing on mass? Let me here. So yeah, so the mass is coming from the core mass accretion, which we're driving from its metallicity. So I don't think we need to set the mass fraction, but we do need to set the mass in kilograms. Okay, so for the sake of getting this in quickly, I'm going to drive the mass manually. But in the future, I'm going to swap it round. So we will take the mean density as our input value and derive the mass from that. So we'll take the volume and the density and use that to calculate the mass, which is basically the same equation, but the other way around. So if we take that a minute, pop that up here. So that's the orbital stuff. It's the radius, so we pop that in there. Actually, we can drive that straight from there. And then that should be right, actually. Let's just grab a copy of that so we can see at a glance what we're doing. Okay, so volume, density, some of that stuff really could be part of the orbital stuff up there. So we need to add mass. I don't think I added mass to the original data. Yeah, that's an example of one of the things that we weren't calculating, I believe. Yeah, none of that was being added, so I have to go and look all that up. Hey, Archer. Yeah, that would be mad. Although now that we are storing the data in a flat database, that actually would not be impossible. The way that this data is being organized is, obviously we've got the XYZ for the star system itself, and that's how we actually extract the data from the database. So we're running a match on the coordinates of the system, and then we're pulling out essentially all the planets that are in that system. The moons and things can be stored in the same way, and we'll have probably an object ID in addition to the base ID, and then we'll use that for parent and child relationships in this structure. So again, another problem that this kind of half solves at this point is multi-star systems and moons, because one of the limitations that we had is that we didn't have the data structure to support that, and this is kind of building on that. So we are solving multiple problems at once by doing this. Yeah, true. Loading 8,000 objects in a system would be a little bit CPU intensive. It struggles enough with 5,000 odd stars. Right, mass. So here we go. Let's work out what all the masses are. Might not. This is going to be an enormous number. Just wondering whether I can store this as a multiple of Earth rather than a straight kilogram value, although a straight kilogram value would be useful. So when we do it here, where are we? Yeah, because that's Earth's mass in kilograms. So that's the kind of size of number we're talking about. So what we could do is work it out as long as we raise it to the power 24, because on Google it's doing it to the power 23, which is no good. Ooh, I might actually already have these numbers written down. Bear with me, I'm just perusing an old spreadsheet. Oh yes, I do. Look at that. So I've got an old spreadsheet here, which is kind of my scratch pad where I do all my math. And I just happened to write down all the values we needed. So Mercury. So do I store it in that format, or do we just give it like hardcore straight up kilograms? I mean, can it even store a number that big? That's the question. Not a huge problem. Right, okay, so for simplicity's sake for now, I think what we'll do is we'll store the values literally in raw kilograms. And then I will refine that in the future a little bit. Let's have a non-separated number. Yes, we can. Right, so Mercury would be that. Where are we? Mercury. It's funny when people say that just a few more Jupiters would make Jupiter ignite into a star. It's like, no. You know, there's Jupiter's mass and there's our sun's mass. I mean, there's a big difference. I think you need something like, I think like 12 to 15 extra Jupiter masses before it becomes able to ignite as a star. And I did not write down the masses of the other planets. Right, let's see if I can find them. Okay, so Haumea. Let's stick them in there. So that times 10 to the power 21. Big number, so that would be that one. And we've got Maki, Iris, and Sedna. That one is that times 10 to the power 21. And then Sedna. Sedna's a weird one because the range is anything from 1.8 to 4.3, which is like quite a big range. There's a big margin for error there. Other places are saying it's 2, so let's stick with 2. Why is Iris so big? What's the radius of that one? Oh, I suppose it is quite a bit bigger. That makes sense. Don't worry, CSI orders them by distance. Yeah, we'll have some weird alien stuff in the game. You never know what you might find out there. Let's just get rid of the commas. So again, working with mass in kilograms is obviously quite unwieldy because it's a massive number. So I'll find a nicer way of doing this so that when we're creating custom systems, it makes life a little bit easier. Why it's not pulling the names off? I'll have a look at that as well. Oh, it has truncated this. Let's hope it doesn't come out truncated, because that would be annoying. So then we're going to set, we're looking for final planet mass. Just realised why the names are not coming out properly. It's because we're not actually grabbing the data. So that should be these guys. So we don't want to generate the names because we've already done that. Just realised why the flavour text is not coming up as well. It's because we are generating it here. We'll just replace the level 3 one for now. Right, let's give it a try. Okay, so we have planet names. That's a good start. Venus is still inhabited for some reason, but we will fix that. Okay, the names are all correct. The order is correct. Distances look correct. Descriptions there are wrong. Okay, so we just need to make sure we're calculating the hill radius and still not showing the mass. Okay, almost there. Oh, well done, Dustin. Congratulations. Oh, wait. That was the wrong way around. There we go. Proper text. Mars is a bit wordy. The other ones are all there. Windows a bit wordy as well. Okay, good. Good. Oh yeah, rings, that's the next one as well. To make sure that we actually are generating rings around these worlds. So do we have, yes we do. So we just need to set that quite simply as part of our data extraction. We don't have a field for it yet, but we shall add one. I'll just store that as a flat 1 or a 0. The other thing we need for that is the ring seed as well. Pretty sure we're doing that manually per planet. Where's our galaxy system? Let's have a look at the Sol assets a minute. So Saturn. Yeah, so we're setting our materials there. So it's using its own custom materials, so that's fine. We don't need to specify that separately. Okay, well, before we just finish off the data, let's see whether or not the planet actually exists. I'm not seeing any, so that's not a great sign. Oh yeah, we didn't set their position in their orbit, so they're all aligned at the moment. It's a well-organized star system. Ooh, it's coming up with nothing on there. That's no good. Not gonna find anything without some coordinates. So we're already setting. So we already have that saved as the star coordinates already. So we should be putting that in here. Is that? Really, that variable should be called? System coordinates, just to make more sense. And because I renamed a local variable, it's now going to mess up in every single place where it's referenced. Okay. It's better, we've got coordinates now. I'm seeing a blue dot, so that's promising. So the question is, will it have a texture? And will it even be there? Partially. That's alright, that actually does make sense because we haven't given it any atmosphere values, so that's not unexpected. Ah, there's all the rest of them. So we do have an Earth, which means in the data we need some additional flags. So we want, does it have a ring? That's just a 1 or a 0. We want does it have an atmosphere? And we also want atmosphere thickness, and we also want atmosphere hue. So that's the Rayleigh scattering, but we'll drive that with a 0 to 360 hue value. Default that to 2, I think. I think it was a 120. No, 220. Yeah, 220 is blue, isn't it? I shall also add ring seed on there. So with the Sol planet specifically, we're not using a seed to configure the ring, we're just setting that manually, but by having the seed in there, it means we can drive other types of planets by giving it a seed specifically. Right now it's not in orbit, it's just sat next to the planet because the planets are not moving, but in the future it will be in an orbit, and the way we'll be doing that is we don't want to go Kerbal level physics, so instead we'll be doing it on rails, which means that it will automatically circularize your orbit around the planet based on altitude. So the closer you get to the planet, obviously the smaller the rail will be and the faster you'll move around it. And then as you move away from the planet, that rail gets bigger and bigger and bigger, and you move slower and slower and slower until such a point as we just delete the rail and assume that you're no longer orbiting the planet. We'll probably use the hill radius for that, just to make it scientifically accurate. But it means that as you fly towards the planet or away from the planet, we'll automatically be adjusting that ring, that orbit, as you go. And the inclination of the orbit, so how tilted it is, will depend on how far above the equator you are. So Venus has an atmosphere. Earth apparently has an atmosphere. Mars has an atmosphere. Ceres does not. Jupiter does. Saturn does. Uranus does. Where are we? Neptune. Yep, Neptune does. Pluto does not. And neither do they. Okay. And then the thickness is going to be 2 for the gas giants, 1 for Mars, 4 for Earth, and 4 for Venus. This is basically driving the material that does the atmosphere. And then all the gas giants have rings. Okay. Right, so we need to check the Mars data for Mars's atmosphere. Yeah, to be honest, every planet has an atmosphere. Like even the Moon and Mercury have atmospheres, but again, they're so tenuous they're referred to as an exosphere. So for the purposes of the game engine, if you can't see it, we'll consider it to not have one. Although in the data, we'll say that it's got an exosphere. Good question, Firstus. I'm not sure. Once we do the sublight stuff, at that point, planets will be collision enabled. Maybe we can do orbits then, because we have to change how the planets are rendered outside of the ship. So right now, all the planets in the star system are attached to a single anchor point. And then as the ship moves, that single anchor point moves them around. But we want to separate them from the anchor point completely so that each planet manages its own position and rotation based on the rotation and position of the ship. Which, because we're unlocking it from a single anchor point, that means that as you get closer to the planet is itself moving closer to the world origin, which makes all the floating points more accurate and fixes lots of the wibbly wobbly problems we have with planetary textures. Yeah, I mean, adding orbits is not specifically required for that, but would be a nice addition. So I think we'll add it to the if we've got time we'll add it list. This is something I spoke with Claire about on our long drive to and from Plymouth, is that we will, with each patch, we'll have like a bit of a wish list in addition to the main deliverables, because we want to make each patch very, very small and very, very quick moving forwards. This current patch has gone on forever, so we want to get away from that. So alongside the main things, which will be like 1 or 2 items at most for the patch, we'll have that laundry list of things we really, really want, and we'll start picking things off that list, you know, as time allows. And I think orbits is probably one of those things. So we shall see. Kind of detab some stuff here. Oh, okay, I did 0.5 for the atmosphere there, and the hue was 10. Okay, I was using slightly lower than 220 for some of those. Right, Mars 10, and then these guys 218, 28. Oops. Keep forgetting, it's not a spreadsheet. You can't just press enter. May as well set those to 0. Oh yeah, Venus. What colour was Venus? Nothing exceptional. Okay. I think I will default those to 0 so that we don't get any weirdness occurring. So the question actually is whether or not, because we're not specifically giving it a color specifically on here. Although we can just make one. Yeah, we'll make one. So on here, yeah, here. So if we make color, no, don't want that. Linear color. No, we don't want that. We want HSV to that's the one we wanted. Right, then we can just drive our hue value directly from there, which solves that problem. Which means we need to add that to this. This is sorely in need of being collapsed into its own graph, but I'll do that when we're at the end. The wish list analysis is a rolling wish list, so the way that we're going to be planning future patches from this point is we're looking at what the gameplay requirements are. So up until now, for the past 3 years, we've been focusing purely on core systems. So doing the galaxy, doing the electrical system, the sensors, it's all been core system stuff. We want to start expanding that out into a little bit more of the gameplay side. So we're going to be doing the patches based on what prerequisite things are required to drive certain gameplay targets. So the next patch, being an example of that, we want the ability to command NPCs on the bridge. So you can sit in the captain's chair and you can basically be the captain and tell the NPCs what to do. So that patch is going to be very much about implementing the things that are needed to make that possible. Things like the ability to spawn an NPC in a chair, the ability to NPCs to be interacted with, the ability to interact with a holo display. So there are various things which make up the overall objectives for that patch. Now alongside that, we're going to have the rolling wish list, which is things players have requested, things we think that would just be cool to add at any given time. And that rolling list of wishes will be basically run alongside every single patch as we move forwards. So after we've done the bridge NPCs, we then want to have a look at sublight flight, the ability for the ship to collide with things, and eventually, as part of that, the ability to go through a wormhole, because it's all kind of connected. And again, that wish list item will be run alongside that patch. So if I'm really bored of working on something, then I'll grab something from the wish list and do that for a day, just to kind of mentally refresh myself. And we'll just keep operating like that. So we have our next gameplay objective, we'll build the things that are needed for that gameplay objective, and then we'll pick a few things off the wish list, as time allows. Yeah, all good, Jason, all good. Well, it would be funny. Maybe just a little box with a red button on it that you can pick up and carry around, like one of those noisemaker boxes. I cannot spell today at all. Atmosphere. Can't remember what I called the row name now. Atmosphere hue. That was one of them. Maybe we'll do that here. So rather than driving the end value like this, so if we put, where's our atmosphere color gone? Yeah, so if I stick that back in there, and we can drive it from here instead, because we're only driving that hue value, and then those are the same. So we have saturation of 0.85 and brightness of 30. The reason that's 30, by the way, which is madness usually, is because of the way the atmosphere shader works. Right, I'm pretty sure that's not what I called the database field, so I just need to check that a minute. What did I call it? Oh, thickness. To be honest, thickness doesn't really make sense either. It's the opacity, so let's just edit that. Atmosphere opacity. Yeah, makes more sense. Opacity. Right, so that gives us our opacity value, that gives us our color and Boolean. So we can pop all that in here. So rings we've set. So it has atmosphere, we're setting that there. We're setting that there. And that there. Okay, we're good. Oh, yeah, of course it's not going to work unless I close the database. Yeah, the planetary landing side of things, I want to start working on planetary landings sooner rather than later, just to kind of prove the tech. So, you know, the way that's going to work has already been pretty well documented, and I want to start implementing that so that we can demonstrate how the procedural generation is going to work on a surface level. Obviously, planetary surfaces are going to be a big part of the gameplay. To begin with, we'll literally just have you teleport down there. Obviously, long term, you'll have to take a shuttle. But for now, we'll probably just put a mock-up of the shuttle in the shuttle bay. So you'll just have to run down to the shuttle bay, click on the shuttle, and you'll just appear on the planet's surface. Just so that we can get it in sooner, get it tested, and start building out that system. But obviously we also want to be able to send down probes and bring things back. So it's whether or not we do the probe gameplay first or the planetary surfaces first. I don't know which of those two we'll do. Probably the surfaces, simply because it's something that I really want to get stuck into. But we'll see how it goes. We're not going to plan the patches too far ahead at the moment, because we want to implement role-specific stuff sooner rather than later, because we're trying to kind of build a vertical slice for the game, and as we work towards early access, we want that vertical slice to contain as much of the planned gameplay as possible, even at a very basic form. It doesn't have to be fleshed out. We want to tick all those boxes to say, right, at a basic level, this gameplay is implemented, and now we just need to flesh it out. So we're going to be basing our patch development cycles on that goal. So we'll go through role after role, adding things for those roles, and then fleshing back previous things as we go. But things like the ability to walk around on the planet's surface is obviously a prerequisite to a whole bunch of stuff. So yeah, we'll take it 2 to 3 patches at a time. I don't think we're going to look any further ahead than that at the moment. Yeah, when it comes to like aliens and alien creatures, then we're going to be paying contractors to build a selection of different skeletons for us that we can use for that. Why? Oh, hang on. Oh, no. Interesting. Why aren't we generating all the planets? Oh, didn't hook that up, that's why. Yeah, so in a word, it's iterative. So everything we do is iterative. So we're starting off with bare bones, with the basics. We're getting it in, getting it tested, and then we flesh it out over time. Right, let's go and visit Earth. So I'm so looking forward to doing planetary surfaces, because it's not just about randomly spawning a bunch of procedural assets. We're also thinking about like what color the leaves should be and that sort of thing based on the star. There's a lot of additional work that's going to go into that, which is the exciting side. Okay, so Earth has an atmosphere and it's the right color, so that's good. go and check out Mars, because that should have a different coloured atmosphere, and it might look a little bit odd because we're using some of the Earth values. Say cheerio to Earth. Oh yeah, the star flare has picked up a bit of a flicker since I fixed the distance occlusion on it, so I need to work out why it's flickering. Probably a little bit too faint actually. I can definitely see the atmosphere is there, but not enough of it. So that needs tweaking. Out of interest, do we have a surface map? Yes we do, so that's good. At least that didn't get broken in the process. Do we need to sort the descriptions out there? Okay, next test. Does Saturn have its rings? Yeah, what Claire said there is true. I mean, normally with a game's development, you see the game at the end of the development process, not at the beginning. And the way that we're developing, we're kind of doing it with a warts and all approach, so you get to see the entire process, even those times where we'll try something experimental, it won't work, so we'll rip it out and try again. Those are just things that you do sometimes. Just want to make sure that the sun occludes properly behind here. That all worked, which is nice. Don't worry, Steve will be coming back at some point. Although, yes, it was Claire that forced me to take him out for the demo because she didn't want to have lawsuits from people having heart problems. Okay, so that worked. I will just check one of those ones because they're flagged as being procedural, so let's go check one out. I do love a nice close ring flyby. Okay, that's working. Make sure it works on the short range as well. Yeah. Looks the same to me. Okay. Right, what else are we missing? So all the gas giant data basically needs to be done. Don't need that. Ooh, orbit position. We do need that, don't we? Are we setting it here? Yes, we are. Are we setting it in the database though? That is the question. Yes, and it's all set to 0. So I think I've never quite understood this, but I believe this is known as the mean anomaly, which is how far around the orbit an object is. I'm just calling it orbit position because it makes more sense in my head. So basically this is a 0 to 360 value, as in, you know, how far around the circle is it. As with most things on here, if the value is 0, then I'm randomly generating the number. So it means that when we're adding custom systems in the future, or when players are adding custom systems, if you don't know or don't want to specify a value, then as long as you leave it as 0, then the system will take over and generate something procedurally instead. So like here, this is setting that to be 0, which means for here, we need to cater for that. So if it's not 0, then we use the position that we've specified in the database. If it is 0, then we need a random float in range from stream. That's 0 to 360, and then we need the stream. Right, and that should fix all the planets being in a line. I'll have a look at NASI and see whether that is in fact the case. Yeah, there we go. Planets are all in random positions now. So I guess the other thing I need to do with this actually is that we're using the average distance to display how far from the star it is. But really, see, looking at Sedna, where is Sedna? So obviously Sedna's orbit takes it, fairly close, and then it takes it miles away. So the distance that Sedna is from the star system is obviously going to change. So really that number needs to be more dynamic. I'll do is I'll do a, once we know whereabouts in its orbit it is, we'll calculate the distance from there to 0, and that will be our distance. Should probably make more sense. This also does, of course, mean that Earth is moved again compared to where we are. So things like, when you press home to target Earth, it will no longer be where you think it is. So the position of the ship right now is where Earth used to be, and now, by the looks of things, it's on the other side of the star. Yeah, it's all the way over there now. So in the previous version of the data, that was obviously here. Basically, yeah. Yes, AJ, basically. The idea behind it is the thrust output of the sublight is multiplied by the FTL field strength, and then the FTL field strength is obviously driven by the reactor output. So all three of those are very organic and will play off of one another. It's going to be interesting and difficult at the same time, because one of the things I want to do is I want to be able to set a specific speed on the helm. So for example, if you want to see how fast the speed of light is, it would be nice to be able to set the helm to 1c, and then you can look out the window and experience what it's like to be traveling at exactly the speed of light. But you need to then work out what sublight throttle percentage do we need, and then what field strength do we need in order to achieve exactly 1c. So that there's a lot of balancing that's going to have to happen there. We can probably math our way through it, but it's not going to be trivial. Thank you, Festus. I think someone asked earlier, actually, what's the maximum sublight speed? Don't know yet. So we've got two options here, basically. Either we allow the ship to accelerate infinitely, obviously up to the nozzle velocity of the engine, which could be a fraction of the speed of light, and then we just let the ship accelerate and accelerate. But if we do that, then when it comes to things like combat and maneuvering around stations and things, it's going to get difficult, because if there's no upper limit on how fast the ship can move, then those engagements are going to turn into jousting matches. So we really want to encourage like two galleons fighting at sea kind of gameplay. We want it to be slow and tactical and positional and really kind of a naval battle in space. So in order to achieve that, we need to limit how fast the ship can move sublight. But we'll experiment with that and have a think about it, when we get to that point. But if we look at the engines that we're using, which is basically sort of Vasmir rockets, the whole idea of those is that they're extremely efficient but very low thrust. So we can kind of lure our way through that, where we're sacrificing efficiency to achieve more thrust. So they're high thrust, low nozzle velocity engines. So that's kind of how we explain away the fact that they're not just able to accelerate forever, by reducing the nozzle velocity. Yeah, it's going to be fun to sort all that out, actually. And when we do the sublight flights, at the same time, we'll probably add a space station or two around Sol and the moon, just to give you something to be able to fly around and kind of bump off of. Yeah, targeting systems could have a track speed limit. So if a target's moving at X velocity, the sensors can no longer track it because it's moving too quickly. There are things we can do, but I'm in favour of limiting the sublight speed in order to close down engagement distances. But at the same time, it's going to remove the ability for people to fly from planet to planet sublight, which I know some crazy people want to be able to do. And if you allow the ship to accelerate infinitely, then that becomes more of a possibility. But yeah, I imagine the system we'll go with is probably a speed limit system. Hey, Binary. And have a good one, Ian. Thanks for watching. Right, where were we? So... yeah, so we were calculating the planet distance there, which is that actual distance, because we've already calculated the local position based on our orbital characteristics. So measuring the distance to 0, 0, 0, the middle of the solar system, does give us our accurate distance based on the current orbital position. So we need to make sure we use this to drive the distance value, which would be atmosphere, physical, orbital. There we go. Yeah, so the average distance, if we use planet distance instead, let's just try that a sec. Ah yeah, there we go. So Sedna is now more accurately a lot closer because we are taking its actual position in its orbit rather than the average. So the average would be over here somewhere, which is obviously much further away. Although they're clearly wrong. Because it needs to be in centimeters, not kilometers. Let's fix that. How many centimeters in a kilometer? Is it like 10,000? Hang on. Oh no, it's 100,000. Yep, that's more accurate. See, this is going to throw some people off, isn't it? So I wonder how many comments this is going to generate. The Earth is 0.99 AU away from the Sun. Obviously, the data here is correct, but you know, it's not a perfect circle. So we do travel closer and further away from the Sun as we go around it. So right now we're 0.99 away. Hopefully, people won't think that's wrong. Although it does make sense for the sensors to show like the current distance, not the average distance. Yeah, I'm sure a lot of people are going to say, oh, it's the wrong distance, it should be 1 AU. Like, no, but not right now, it's not. Okay, what else are we missing? Oh yeah, we need some lifey stuff, don't we? Okay. Ah, my eyeballs. So this will be under the star system data itself. So we've got, yes, we need to know the details for this. So I think 0 was democracy, 0 was mammalian, I think 1 was monotheistic, and then we were averaging those at 50. I'm going to change this. So I think I was in a bit of a fever dream when I did this the first time round. so I tried to do a bell curve with 50 in the middle, where we take 50 as the galactic average for aggression and xenophobia, and then a race kind of falls away either side from that 50 in a bell curve. Meaning that humans were right in the middle at 50. But it's been quite widely misunderstood as 50 being a high value rather than being the 0 point. So I think we'll just do 0 to 100 and keep it simple. So 0 is like not aggressive at all, and 100 is psychopath. So we need to grab all of those columns. Yes, Anasi. Although no, more accurately, what we'll do is we'll work out using planetarium software where everything should be in the year 2261 and then move it accordingly. So the starting position will be where it actually would be. But again, I think I have to convert mean anomaly into some kind of 0 to 360 value. I think that depends, CSI, on just how much power is being generated. So the solar panels on the ship, I think would be quite cool if you deployed them around the ring. So if you have the ring just kind of like stretched out solar panels a bit around the outside, and then you point the ship out the star, then that's the power you need to recharge the star capacitors. Similarly, the reactor on a shuttle, given that it's got any fuel, should be enough to charge the star capacitors. I think once you start going down into like generator territory, you're probably looking at not enough power. Yeah, I think if you stretch some bed sheets across the ring, you could probably put together a solar cell. I'm not sure the ship contains enough linen for that, but you never know. Right, so race name, race tech level. Did I already do race name? Oh, hang on. Hang on a minute. We don't need to do that there, do we? Again, please do hold your judgment when it comes to this blueprint. It will not stay like this. This is what my blueprints look like. All nice and clean and tidy and well documented. This is very much a work in progress. Okay, so we're generating a whole bunch of data here. Thanks, CSI. Right, where are we setting the name? System name. Did I already do it? This is a perfect example of how my week's gone. I've obviously actually already added all of the data for the race stuff. And I've got no memory of doing this. And yet I would have done it in the past couple of days. Like, was I asleep when I did this? Oops, close the database. I did do it. Weird. Yeah, I must have been. Or half asleep. Still don't quite understand why Venus is showing text signatures though. Just trying to remember what the criteria was for that. So we had, if it was an Earth-like world and we had a Civ name, then we were showing a text signature. So why is Venus showing one when it's definitely not an Earth-like world? To change the atmosphere on these gas giants to say significant as well. Okay. That's true, life has indeed found a way. So I don't need to worry about the Civ stuff because apparently I did that in my sleep, so that's good. Right, let's add some of the atmosphere stuff for the gas giants. Right, so final planet mass we're already doing here. There, so we don't need to calculate that anymore. So that's the volume, that's the mass that we've already taken. That gives us our mean density. So we don't need to do that because we're already doing that. So we don't need that. Means, to be honest, we can add that to that because it's not necessarily gas giant specific. Yeah, as long as we're chucking some valid mass values at it, then the density should be accurate, and the volume is easy from the radius anyway. So mean density we're calculating there, which gives us our Roche limit, and then final planet mass, is that one? Yep. It says square root. Now we're getting some values. That looks good. Okay, so we're just missing escape velocity. Make sure, yeah, So again, we need to make sure that the calculated values are accurate to our stored values for Earth, which it is, so that's good. It's an interesting one, actually. I like it when procedurally calculated values are that close to the real value. So before we were manually specifying this, but it's nice that it's worked that out based on the orbital distance and the bond albedo. It's calculated the equilibrium temperature itself, which is not far off what it should be. So that's nice. Gravity's bang on. Volume's bang on, which you'd expect because of the radius is manually specified. Yeah, density is an interesting one because, again, that density value, it's calculated itself based on the mass and the volume. So, yeah, for it to hit bang on 1 times Earth, that's pretty good. It's just a nice bit of validity that the math is correct when you get a nice value like that. Okay, so the gas giant values should be comparing themselves to Jupiter, not Earth. Not quite sure why they're comparing to Earth. So I shall have a look at that. Yeah, thanks for pointing that out, CSI. Okay, so escape velocity. Let's add that one. Actually, while we're here on this, so this is like the biggest macro I've ever made. It's mental. That's the star. So we want sensor output for the planet. That one. I think I actually just built in Earth as a hard-coded reference, to be honest. Yeah, so I need to do a second one of these comparing the same values against Jupiter. So if our planet type is a gas giant, which we're not tracking, but we can, oh yeah, we're tracking it there actually. So yeah, so from this struct we can pull out our object type, and that's how we know if it's a gas giant or not. So if it is, then we can compare the value to Earth. So obviously that's the Earth value there. We just need to double this up, put Jupiter's value there and put X Jupiter instead, and then drive that from the object type there. So not difficult, just annoying, which describes most things, to be honest. So we can probably pop escape velocity down here as well. So we've got big G, we've got our mass. I think we'll replace that with that instead. So we got our final mass, we got our radius. Why are we typing that by 100,000 even? There's probably a reason for that. I need to remember. I need to remember to add little notes on those to remind myself why am I doing that. Okay, so those are the extra bits there. So I think overall, the only thing that's proprietary to gas giants and terrestrial planets is going to be some of the surface stuff and the atmosphere stuff. Everything else, I think, is the same for both of them. It wouldn't be, and it's not here, because obviously we're on the procedural planets. We're doing the core mass accretion and then working out whether it's a gas giant based on things like can molecular hydrogen escape that planet. But with a manual one, we're doing it manually, so we don't need to do any of that working out. So a lot of the stuff we're doing here we can just skip and just throw some values at it, which does also really mean that we can probably add all of that to that. Again, forgive the spaghetti for now, this will improve. Right, so those are all the unified values that apply to everything, and then these will be the object specific calculations there, and then that's just building the final object. That's relevant to that, so it can stay there, we don't need that. Okay. Going to check the escape velocities now, make sure they're right. Yep, bang on Earth, which is good. So with the age display here, I think I've put 4.603 billion years. Not sure why it's 1% off, but Yeah, I'll have a look at that. And the equilibrium temperature, I'm amazed it's as close as that, to be honest, given that it's calculating it automatically. So I'll just adjust the value a little bit. Earth's equilibrium temperature is... What is the Earth's TEQ? No, it's just trying to sell me T. Earth equilibrium temperature. So Earth's equilibrium temperature in the absence of an atmosphere is around 19 degrees C or 255 Kelvin. And we're calculating it at 257, so that's pretty much close enough, I would say. And then all of those should have escape velocities. Okay. Right then. So, atmospheric composition. I suppose, to be honest, we need to be entering this manually, don't we? Yeah, otherwise we're going to get a procedural value which is pretty far from ground truth. Okay, so if I grab so we do need to set that. We don't need that. So that one, that one, that one, that one. So average temperature is going to be the same as the equilibrium temperature, which we are doing somewhere. There. for a gas giant, we're just using the equilibrium temperature as its temperature, because it doesn't really have any surface heating that we need to worry about. Whereas for atmospheric worlds, we need to take greenhouse gases into effect. So the actual average temperature is going to be a lot higher than the equilibrium temperature. Where are we doing a basic version of that? Here. Yeah, so I think what we'll do with this, if we take our equilibrium temperature and then we will multiply that by a range. So actually no, we don't want that one, do we? We want our atmospheric opacity. So this basically goes from 0 to 4. So if it's 0, we want to multiply equilibrium temperature by 1, as in there's no atmospheric heating at all, up to, what would that be? I'll do some math over there a minute. So yeah, I think it's only 10%. Yeah, it looks like it's about 10%, so it's going to be wrong for Venus. I might have to do that one manually as well. I will do it manually. Because we don't have the atmospheric data calculated yet, so we can't accurately work out the greenhouse effect. So until we have that, we've got no choice really to specify a manual temperature for these particular worlds. So we just need an atmospheric temp value. So atmosphere temp. Did I need anything else? Oh yeah. I suppose as well, yeah, because we need to specify these manually too, don't we? Again, because we're dealing with real planets, we need the real data. I think the way I'll handle this for the procedurals, well, for the handcrafted in-game tool. So when we're doing the star system designer, I think what we'll do is maybe add a random dice roll button. So if you don't want to get your hands dirty doing the math and working out the mass fractions of each element, you can just mash a random button until you see some values you like. It's probably the easiest way around it. Oh, good night, CSI. Have a good one. Right, yeah, so we need to... so we need a hydrogen fraction. I'll just call it hydrogen for simplicity's sake. Helium. Other. What am I using for the gas giants there? So, oh yeah, methane as well. Yeah, so we can use some of this data for the star as well, which makes life a bit simpler. Yeah, so if we make that one methane, and then other. When it comes to the terrestrial worlds, obviously we're going to need a lot more chemicals than that. A lot more chemicals than that. See you, Zockbox. Have a good one. Right, so we know that Earth has an atmospheric temperature of 288 Kelvin. Right, so Earth. And then Venus is something stupid. We got 737 Kelvin, which is 867 Fahrenheit or 464 degrees C. Very toasty. So Mercury is going to be equivalent to its equilibrium temperature. Mars won't be. 210. Suppose I need to add the average values for those. Well, I don't know what I'll do is I'll put a switch in there, so if it's 0 it will use the equilibrium temperature. That means I don't have to type it in all of them where it's not needed. It's only the atmospheric ones we really need to bother about. Right, and let's look at the sun mass fractions a minute. Sun. So the sun is made up of 73.46% hydrogen, 24.85% helium, no methane, and 1.69% metals. Basically everything else. Jupiter. So Jupiter is 89% hydrogen, 10% helium, 0.3% methane, and that'll do. Saturn is 96.3% hydrogen, 3.25% helium, and 0.45% methane. Typically cannot find the values for Uranus. Move on to Neptune in a minute. There we go. See, nice simple values. That's what I like to see. So 80% hydrogen, 19% helium, and 1.5% methane. Granted, they're probably estimates. Uranus is 83% hydrogen, 15% helium, and 2.3% methane. Insert joke here about methane being the largest fraction in the solar system. Save all that. Yeah, I'll I'll have to fudge the numbers to make them add up. Why would they produce estimates that don't add up? That makes no sense. Check the sol value as well. Yep, that one's all right. Right, so we've got our mass fractions, we've got our atmosphere temp, so let's add those. Even more lookups. So if the value is greater than that, then we'll use it. Otherwise, yeah, otherwise we'll have to generate it. Oh no, we won't. We'll use that. Be gone. Yeah, so if we've specified a manual value for the temperature, we'll use it. Otherwise, we will use the equilibrium temperature. which will do us for anything rocky or anything we don't know the temperature of. And then these guys, stick them over there. Right, and I will just zero these out. So if it's a terrestrial planet or otherwise rocky, we will just zero those. Because they're only relevant for gas giants right now. Hydrogen. Helium. Methane. And other. And obviously for terrestrial planets they will be 0. Actually, yeah, so I don't even need to zero them out because they're already 0. Should not be required. So really we're doing very little at the moment, different depending on the planet type. To be honest, even that's kind of superseded by that, but leave it there for a minute. So there is one thing we're probably missing with this, and that's when we do the central star data. So we're grabbing the name of the star, but we're probably not calculating this properly. Unless we're doing it here. No. We're not using that for anything, are we? Yeah, so age and mass comes from the main data, so we're skipping it there. But ideally, we need to insert these values before we calculate the size of the protoplanetary disk, because that takes some of these mass fractions into account when generating the disk. So we could do a calculating that beforehand, but I think for now, yeah, we grab grab those variables, and then we will define those in here. Again, this craziness will be cleaned up. So in this case, we're interested in the hydrogen. Helium. And the other, which is essentially the metals. Right, so we should now have that data available on the star. Okay, I need to store that data differently, don't I? So these need to be stored as, so that would be 0.7346, 0.7346, that would be 0.2485, and that would be 0.0169. And the same here as well. So 0.80, 0.19, 0.01, 0.83, 0.15, 0.02, 0.963, 0.325, 0.045, 0.89, 0.107, and 0.03. Okay. That's better. Okay, so other than calculating the scattered disk, I think that's exactly what we want. And I think, again, given that this is not a procedural system, I think we'll specify that manually. And we'll do that as part of the system data. And then, so these ones shouldn't have anything there, which is fine. And that one should. guessing I called other something else then. Yeah, so it's picking up the right temperature. That's correctly 0. That is not correctly 0. So what did I call it? Earth and Mars should have the colonies, yeah. Oh, hang on. Sorry, I wasn't watching chat. I missed that. Saturn. Oh yeah, well spotted. So 0.0325. Well done, thank you. Oh yeah, we're not saying an other on there, are we? Yeah, we're missing some other values, and I'm sure we should make some allowance for that. Okay, it's trace amounts basically, so it's not something that it's really going to show up. All right, not to worry. Yeah, we can just calculate it, but the problem is these all add up to 100, so it doesn't really leave anything left over. I mean, we could have it say trace rather than 0. That would probably look neater. Yeah, so yeah, we could have trace amounts of something else. I just realised actually we're missing methane from the list on those ones. So yeah, it's think what it's doing is using what we were using for the star. So that other really should be methane. So that would need changing. Okay, so that should sort that aspect of it out. And then obviously on here we need to make sure that we rename it accordingly. So where are we? Alright, so that's for the star. And then for the planet, there we go, other. So that should say methane. And we'll have to do the same thing on these ones as well. So there, and also on the short range. Right, let's have a look. So on the long range mode, we're seeing, yeah, there we go, hydrogen, helium, and methane. They all have values. And then we should see the same data on the medium range. Yep. And then the same on the short range if we're near one, which we're not, but it will be the same. And then 0 for those. Yeah, brilliant. Okay, so for the gas giants, that needs to be compared to Jupiter. That's kind of a slightly bigger job. That's all the data there for those. Oh, hang on, let me have a look. Oh yeah. Just checking that it should genuinely be 0.3. Yeah, that's right. Okay. So I think that's everything. So just give that another test a minute. Right, so on the long range, picking up the right default zoom level so that it's showing the whole system. I'll figure out Venus at another point, but oh yeah, we need to do the scattered disk, don't we? But I think that's the only thing that's left. I think everything else looks good. Okay. Success. Oh, don't worry, Fred, I'm glad. It's helpful. Internal structure of the ship. Layout-wise, I think we're pretty much locked in on where the rooms are going, what the rooms are used for, and just the general layouts. Now, a lot of the outer areas are still grey box at the moment, so they don't have the actual final modelling done. So I suppose if you're looking at it in 3 layers, you've got the actual layout itself, I'd say 95% done. The structural framework side of things, I'd say about 50% done. And the actual internal geometry, like the actual detailing, I'd say is 20% done. So there's still a lot more to do on that. Right, so let's enter the data then for the other system, and then we can actually remove a bug from the bug tracker, which is why I started all of this nightmarish hellhole of a rabbit hole in the first place. So the original bug was that we had no data for the Loki system. Right, do we have any real-world data for that? I seem to recall that we didn't. Okay, so roughly 73%. Sorry, so that would be like 0.73%. And roughly 25, which would mean roughly 2% metals, which would give it a metallicity greater than that of Sol, which would be wrong. So yeah, that can't be right, surely. Surely not. So if we make that, maybe give it a 0.26 and make that 0.01 instead, or maybe 0.255 and then make that 0.015, so it's a bit less. Because it's an M-class star, so it shouldn't be generally as metallic as a G-class. We don't have any flavor text yet, or a race name yet. But now we need to add planets. So this is basically test driving the system for adding custom planets. I might have fixed that one, Anasi. What I've done is I've increased the packet limit size on the replication, so hopefully it will now fit the actual system data into the packet and won't lag like it is now. So fingers crossed that is actually fixed. Yes, Glenn, exactly that. Here is one I prepared earlier. Ta-da! So we've already got this star, but we need to add the star as an object. So this will be the first one in the list. Again, some of this data is wrong, so we just need to make sure that we add the correct data. It's a book by Drew Wager. I can never pronounce his surname right. Is it Wager? Wager? I think it's Wager. I have it here, actually. On my shelf somewhere. Hang on. I've been moving all my books around, so I don't know whether I have it on here. Where did I put it? No, it's not that one. Well, I do have it here somewhere. No, don't know. Are you close? Yeah, there it is. Knew it was there somewhere. This book by our good friend Drew. Highly recommend it. Yeah. Yeah, feel free. If it won't let you do it, then I'm sure Claire can do it for you. Right, so we need to add, first of all, the star. So if we so that would be M class star. I think it's an M2V class star. And the Chi 9352. And that was all the sixes, 0, 57, or 157, I think it was. 146. Seed would be 0. Did it let you post it, Glenn? I don't know whether the settings are such that it deletes links. If so, then if you send the link to Claire, she can post it for you. Or she might even have it on hand even. Right. So the next one is... I'll fill out all the details afterwards. So we've got Miura. Make sure I get the right type. Oh yeah, so that was the really hot gas giant, wasn't it? So that would be unknown. Class 4 gas giant. Thank you, Claire. Okay, and then we have the tidally locked Earth-like. It's not actually an Earth analog because it's an eyeball planet, but it will do for now. I think that was the desert world, wasn't it? I think this one was Furia, if memory serves. Is that the next one? Yeah, with 1 R. I did have some descriptions for these written out. Not sure where they've gone now. Partially, Anasi. So we've already got the code in place for being able to, rather than having like polar ice caps, having like the eyeball planet design where you've got essentially it's a mask. So you've got one side of the planet which is iced, the other side is like terrestrial looking. So all the mask and everything's all built for the worlds. It's just we haven't added the code yet that works out whether they are tidally locked. So we take the lifetime of the planet, so the planet age, and its orbital characteristics, and then we need to work out, given the amount of time that it's existed, has that been enough time for it to become tidally locked? And if so, then we'll make it a tidally locked world and apply that mask to it. But we need to do the mathy bit first, which we haven't done yet. Right, so we add those. What's he complaining about? Oh yeah, renamed it, haven't I, to ID. Bosh. Right, so we now have the data for those worlds. So that one can be staying at 0, 0. And then we need the orbital data. Might have to add a bit of randomness to this because it's in an absolutely perfectly circular orbit, which is not realistic. But do for now. So radius. See, this is where we need to work out the mass, and this is where using the mass in kilograms proves to be troublesome, because now we need to work out what the mass of this world would be given its radius and typical density for a gas giant. I'll have to calculate them offline. And it's well hot. Although we'll let the equilibrium temperature work that out, I think. Oh, hang on a minute. I put the wrong value in the wrong place. I was doing randomness after all. Right, so if I make that times 0.99. There we go. Gives it a bit of randomness. Okay, so atmosphere, yes. Atmospheric capacity 2. Hue would be 218. Let it drive that itself. So we'll have to make up some mass fractions for that. Let's say 0.87. Based on the other planets there, so let's go for 0.0035, just as a random number. So that would be 1 minus 0.87 minus 0.0035 gives us 0.1265. There we go. I don't believe there's any mention of a ring, so we'll leave that at 0. Next. Now we've had Drew's system in from the beginning in ASCII. This is just me repairing the data and putting us in a situation where we can actually flesh out that data. Let's multiply this one by 0.9957. Oops. Let's try that again without fumbling it. Okay, and then the radius is that. We don't have a mass yet, we need to calculate that. Yes, it has an atmosphere, and that would be 4, and then 218, and the atmospheric temperature would be that. So very similar to Earth. Don't need to worry about the rest of it. Next. Yeah, Drew was really kind to us over our Kickstarter period and helped publicize the game, or push our publicity for us, which we are eternally grateful for. So us putting his system in the game was just our way of saying thank you. Oh yeah, I forgot the inclination data. We need to set the system inclination as well. Yeah, absolutely. See, I used to listen to Drew long before starting this project. So back when I was pretty much just playing Elite and not really doing any development work, just playing it as someone who loves Elite, I used to watch the likes of Obsidian Ant and Drew. And it's so surreal to have gone from just another gamer who plays Elite, watching these streamers, to being a developer of a game where those streamers that I used to watch are now showing my game. It's this really weird, surreal situation that I still haven't quite got my head around. No, although Sad J should be one of them. I just haven't added that yet. It still added the manual way as opposed to the new way with all the new data. Okay, I do have some descriptions on here. Hang on, let's see if we can get some of this in here. So yes to an atmosphere 4. Let's go for a Mars-like hue, so it's a lot redder. There it is. That's the description I was looking for. I thought I had some descriptions of the other ones as well, but I'll have to go back through my notes for that. Have a good one, Duran. Thanks for watching. I shall be off myself soon. It's almost at the 4-hour mark. I'll just get this done, test it in game, and then I shall call it a night. So I haven't given a unique ID to these. Actually, though, I will set them to 1 because we're using 0 specifically for stars. But yeah, they don't have their own custom planet type. So that might actually mess up the random generation of a seed. So I might have to put an is star flag on here rather than using 0. And then I can use 0 for the seeds so that it randomly generates them. Okay, and then we need to also... So I'm just thinking about Kuiper belts and things. I suppose that's better placed on here. Yeah, so if I add a couple more fields on here for Kuiper start and Kuiper end. You can tell it's late. I've lost the ability to type. Sticking some zeros into there. Let me, thank you. Right, then we need to work out what that would be in centimeters. So let's work out Earth's one a minute. So the Kuiper belt starts at 30 AU and runs to around about 50 AU. Okay. Let me go to length converter. This is one of my favorite websites because you can literally type in like 30 astronomical units and have that in centimeters, and it gives you the actual proper number rather than like truncated versions of it. Makes life much easier. So Kuiper belt start would be that, and then 50 AU would be that, and then if we take the extent of this one as where that's starting, so again we can do this the other way round, so if we do that many centimeters in astronomical units, if I can see them, oh, that's tiny. What a remarkably small system. Okay, so if we go 0.75 then. So 0.75 AU would be that. And if we make that, I don't know, let's say 0.8, because it's such a tiny system. And then we can use that to drive just some like trans-Neptunian objects like Pluto Sedna and that lot. Okay, so that's the Kuiper Belt stuff done. We've added the Lakai planets on there. So on this side, let's just close the database. So I suppose we just need to load up the Kuiper start and end here. So that's Kuiper start. And Kuiper end. And then we should have some values for that on here. So we've got that. Sorry, that's my phone. Okay, I'm storing that as kilometers. Okay, I have to multiply that a little bit. So multiply that by 100,000, which is centimeters to kilometers. I always forget to add little notes like this so that in the future I'll look at this and think, what on earth was I calculating there? Now I know. Right, so that should store that, which means once we get down to all the way over here, we should be using the same values. On the star, which will be here. There we go. So yeah, so we're using those values there. So we're generating them there. Yeah, that's good. No, it's fine. It's one of those things that we're doing kind of backwards. So we're updating the data there after the fact because we've had to work out through mass deduction from the protoplanetary disk at what point we run out of mass for planets, and then we know where the scattered disk should start. But when we're defining it manually, we don't need to go through that rigmarole. But what we could do maybe if we take a copy of no, I won't do that actually, no. Because what we could do, we could actually build a scattered disk of random objects off of the manual data, but we're already manually placing some sol variants. So I think rather than having kind of a 50-50 overlapping system where it's kind of filling in blanks procedurally. I think if we're going to make a manual system, we kind of need to bite the bullet and make it a manual system rather than kind of being lazy about it. Because otherwise we start to have too much overlap. Right, let's just make sure that we have the values there and make sure that Loki is there. Okay, there we go. So, oh, that's a massively wrong number. Should look into that. That's way wrong. Oh, wait. Yes, I shouldn't have times it by 100,000. I should have times it by like 0.0001. I needed to do it the other way round. Yes, so that's in the data twice at the moment. So I don't think we have Loki in that data. So we've got the modded data there. Yeah, that's got nothing in it. We've got 2,000 light year range, and I don't think it's there. Yeah, we've got just the other version of it, so it's not in that data, which means it must be on the web data. Bear with me a sec. I think I've added it to the backer systems data, so I just need to check the database a minute. Backer systems. Or not actually, it's not on there. Alright, where's Loki coming from? So we used to do a specific check on whether or not it was a custom sector, and then we would render that sector separately. So the sol sector would be custom generated, but we don't do that anymore. Right, so I'm going to disable backer systems a minute, just to like absolutely verify that that's not where Loki is coming from. Nope, definitely not the backer systems. So is it coming from the real world data? Yes. So it is in the real world data somewhere. Let's see if I can dig that out. So this should be the manual version that we made. So we've got Sol and Loki. Oh, of course, we didn't set an object type, did we? Hang on, let's fix that in the data a minute. Yeah, so planet type. So we need to set these here. So just to remind ourselves, that was there. So class 4 gas giant is 25. So that's 25. Earth-like world was 20. Okay, look like we got rocky with atmosphere, and rocky. So that's 18, 19, and 18. 18, 19, oops, 18. Right. They should show up properly now. That's better.
Initiating long-range survey. Long-range survey complete.
Okay, so if we send that one to the helm. Obviously the Roche limit and the hill radius and everything, we haven't given it a mass value, so it can't work that out. I shall cheat our way there. I did see the sun for a moment. Are we behind something? Must be. Yeah, we were. Typical, we appeared on the wrong side. That does not look very Earth analogy to me. Let's check that one out a minute. Make sure that our object classes are set properly. Okay, that's definitely not a gas giant. Okay, so the names are correct. Yeah, that data's correct. So it must be the actor type not spawning the right type of actor. So definitely setting that one to 20. Oh, I think I know what's happening there. Of course. Of course. We're using the seed of the planet to define what type of object it is, what type of actor it is. So we need to specifically override that for the Sol system, but not for any other system. So I think that needs handling differently. So rather than using the seed to drive the type of planet, we use something else. I think for now we'll just have to add them on there. So we've got hang on. So if we make that 15, 16, 17, 18, and 19. So 15, 16, 17, 18, 19. Then we had Yeah, that's right, actually. Yeah, so we need a better way of flagging whether or not it's going to be a procedural planet or a pre-textured planet. And we need a better way of flagging that than doing this. So I think we just have a Boolean value for textured or like pre-textured planet. Then we can switch on the seed to identify which texture. Otherwise, it defaults to a procedural planet. I think that makes more sense. Oh, forgot to close the database. There we go. Okay, so do that one. Let's go to that one. Do that. Do that. Do that. Do that. Teleport over there. It's probably placed us behind it again. Oh, I see life. That's a good sign. Although Asurio shouldn't have life on the dark side, but that'll be fixed when it's an eyeball planet properly. That's better. Right, so we know that one works. Let's just check that gas giant. Nice and close to the star. There we go. And we have a gas giant. Very hot gas giant at that. Ignore the fact it keeps going dark. That's just auto exposure, which is on my test map for some reason. Checking that it glows, which it does. I love these gas giants because you can actually see it glowing from the opposite side. Gotta love a good class 4. Yes, Glenn. So the seed value, we can use that directly to drive what it looks like on the surface, like with all the continents and everything. So when we do the texture gen for those, then we can just pass in that seed directly. In fact, that seed is driven. Put that back in so it's not quite so broken. Hang on, let me just save that because otherwise I'll unplug it and forget that I've unplugged it. Yes, so we drive the seed here like this. So if there is a seed, it will use it. If not, it will randomly generate one. And now right now we're putting a seed value of 1 for these planets to stop it from randomly generating them. And because we need it to generate this, So once I've replaced this with a Boolean value, it means we can then specify the seed in the data. So I open the database again. It means that this ID column here, I can rename it to seed. And then that's genuinely the seed for that world. So you can just change this seed value and it will change completely what the planet looks like. Yeah, we needed to put 1 in there so that it would pick the right type of planet. And it was making everything look like Mercury because 1 is Mercury. Okay. So there we go. We can finally close that bug. Well, finally close that bug once I've worked out where in the real world data it's getting that from. Actually, let's have a quick look. So it's pulling Loci out of this database here. But I'm not seeing it. Although this is truncated, I think. So let's start from stars where name 1 equals Loci 9352. I think I can do that. No. It would definitely be name 1. It's definitely in the data somewhere because that's where it was coming from. Can't remember, to be honest. There's probably an easier way that if I do where x, y, z equals x, y, z. In fact, I don't think we need them even. So it's 26, 666, 146, I believe. Oh, and there it is. Oh. Have I been spelling it wrong all this time? No. That's really funny because this is coming straight from the Gaia dataset. So it's spelt wrong in the Gaia dataset. That's really weird. Oh well. If we just do delete from stars where blah 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 blah. Okay. And that should have fixed it. Ah, okay. Well, it wouldn't have found it anyway because it was spelt wrong, but right, there we go. Just one entry and it is the correct one. Jolly good. Yeah, I don't know why it's spelled with an E in the Gaia dataset, but what can you do? It's that whole garbage in, garbage out problem, isn't it? Right. So after a week of rebuilding all that stuff, we can finally say that bug is now fixed. What build are we even on now? It's 103, isn't it? It's nice to have finally fixed that bug. Just updating my notes a minute. Okay. Too many tabs. Okay, I don't need that anymore. Okay, there we go. We've overrun by half an hour, but at least we got it all fixed. So that's the main thing. I shall call it a night there because I am sleepy and I have bum ache. So I need to get up and have a stretch. And then I shall tidy up some of this stuff and I shall put a build out. And then we can test that multiplayer sensor lag actually, so it'll be good to get that tested. So I shall wish you all a good rest of the week. And I've just remembered I need to put my bins out as well, so I shall go and do that. Have a good one, everyone, and I shall see you on Sunday stream. Bye for now.